Good afternoon, students. So, the topic today which we are going to discuss is the precipitation. Okay, so in the last class, I had discussed the different types of humidity as well as the condensation process. Also, in a brief, I have discussed that the condensation process from the syllabus it has been excluded, so we don't have to study. Okay, like different in the book, if you see different types of clouds and like the upper clouds, middle clouds, lower clouds has also been discussed. That all has been excluded from the syllabus. We don't have to study that. So directly we will be moving on to the explanation of precipitation. Okay, now precipitation means like the condensed water vapor, as I said, the condensed water vapor, which the water droplets also we can say, which condensed around the dust particles, and due to the agglomeration or due to the collection combination of millions of other dust particles and crowd like water droplets, they led to the formation of clouds, isn't it? Now the clouds, when they it becomes heavy and can't remain suspended in the air, okay, it will fall down on the earth's surface. So that falling down of the clouds also, or we can say the condensed water droplets, okay, that when it falls to the earth's surface is termed as precipitation. Now the precipitation are of different forms. Now when the precipitation in the form of liquid, when it falls down, they are termed as rainfall, okay, or it is also termed as drizzle. Drizzle, okay, it is also termed as drizzle. Okay, so it is termed as drizzle. And another one, when it forms in the solid, okay, then we have here sleet is also there, one. Then we have hailstone is also there, and snowfall is also there. Okay, so in the form of liquid, the precipitation when it falls down, it is rainfall or it is drizzle. And in the form of solid, so the difference between the rainfall and the drizzle, okay, now if the droplets, if the size of the rain droplets when it falls down on the earth's surface, if it is less than 0.5 millimeter, okay, 5 millimeter, then we term it as drizzle. Drizzle. Now in case if it is more than 0.5 millimeter, then we term it as rainfall. Okay, now whenever we say light rainfall or moderate rainfall, or if we say heavy rainfall, it does not include the size. Remember that. Okay, it is not on the basis of size, it is on the basis of the intensity of the rainfall. Okay, so whenever it is said light rainfall, moderate or heavy rainfall, thus it is not determined on the basis of the size. Okay, it is basis on the intensity. Okay, now light rainfall means very like the shower which occurs, it is very light or less amount. Okay, heavy, moderate, so in that way the intensity will decide the the different types of rainfall also. Okay, now the size will determine is the difference between the drizzle and the rainfall. Remember that. Okay, so when it falls on the precipitation, when it falls on the liquid, that is known as rainfall, and drizzle, solid is sleet, hailstone and snowfall. Now snowfall we all know, isn't it? Whenever the difference or whenever the temperature, okay, um, near the ground surface as well as in the upper atmosphere, so whenever the temperature near the earth's surface, okay, supposingly this is the trees and all which are present, okay, so near the earth's surface as well as in the upper atmosphere, if it is below minus or in the below 0 degrees Celsius, then instead of the droplets, a six-sided cube will form. Okay, six-sided cubes will form. Okay, now small light six-sided cubes will form. Now those kinds of solid objects when it forms below, or due to the less than the temperature of minus 0 degrees Celsius, okay, then what happens below the freezing point? Now those six-sided cubes, when they fall on the earth's surface, okay, that we term it as snowfall. Okay, that we term it as snowfall. Now next is sleet. Let's discuss the sleet. What is sleet? Now when the rainfall and snow, when it occurs together, we term it as sleet. Okay, now here what happens is, in case if the ground temperature is more than freezing point, okay, but at the upper level or in the upper atmosphere, if the temperature is less than freezing point, then what happen, it will lead to the formation of a snow crystals or the ice crystals at the upper level. Okay, now when those ice crystals, now it will also be form of the varying size, isn't it? It will form of the varying size. Now some will be bigger, some will be smaller. Okay, so when it falls down on the earth's surface, the smaller size ice crystals, okay, when it reaches the earth's surface, it will melt because the ground surface temperature is more than the freezing point. So it will, when it falls, finally when it reaches the earth's surface, it will convert into the liquid, okay, due to the melting of that smaller size ice crystals. But the bigger ice crystals, it will not melt down completely, okay, only a part of the ice crystals will only melt, so it will fall on the earth's surface in the form of a solid ice crystals only. So the smaller will melt down and it will take the shape of the liquid, and the bigger size ice crystals will partly melt and it will fall on the earth's surface in the form of a crystals only. So here if you see, both the rainfall as well as the snowfall, when it occurs because of the varying temperature at the upper atmosphere and at the ground surface, then it is termed as sleet. Okay, now the next is hailstones. Now hailstones, we all know, isn't, we all have experience also, isn't it? Now hailstones, it differs from size to size. It may be hailstones, it may be of the size, for varying of the size 5 millimeter to 50 millimeter, okay, of hailstones of the size may vary. Okay, now what happens over here is actually due to the convection, suppose this is the earth's surface, the convection current, okay, means the rising air from the earth's surface. What it does, it actually, when the rain droplets are falling, okay, the rain droplets are falling towards the earth's surface. Now due to the convection current, if the convection current are more, okay, or the convection current is force of the convection current is much more higher, or if it is more, then those rain droplets will be blown away in the upper atmosphere. Okay, it will go up in the higher atmosphere. So when it goes in the up in the higher atmosphere, due to the the decrease in temperature, those rain droplets will convert into the ice crystals, thin ice crystals, thin layer of ice crystals. Now those ice crystals on the due to the force of the gravitation, again it will fall down. Okay, but what happens, the convection current will again raise those ice crystals above. Okay, now there what happens is, the another layer of ice crystals will be deposited over that layer. Okay, so again it will fall down, but here what happens, again due to the convectional current, it will be raised above. Then another layer of those the ice crystals will be deposited on them. So it will be raised along the convection current to the higher level of the atmosphere, until and unless it becomes heavy. Okay, and the convection current won't be able to raise it at the higher level. Okay, and as a result, due to the force of the gravitational, okay, or the gravity, finally it will drop into the earth surface. Okay, now those kinds of ice crystals are termed as hailstones. Okay, so it the hailstones are there are formed due to the deposition of the different ice layers. Okay, so that is your hailstones. Now the most common type of precipitation, if we say next we discuss, is the rainfall. Okay, because the hailstones or the snowfall or the sleet, they are not very common phenomena. It is very rare phenomena. Every time the rainfall, when it occurs, we don't observe hailstones, isn't it? Now in the higher altitude or in the higher latitudinal places only we observe snowfall or the sleet, but most of the earth's surface, what they observe the form of precipitation is the rainfall. So the most common type of the precipitation is rainfall. So it is also, the different types of rainfall are there, that also we are going to discuss now. So the most common type of the precipitation is rainfall. So it, as I said, there are different types of rainfall. There are the convectional rainfall. Okay, then we have relief rainfall, or also it is called orographic rainfall. Okay, then we also have another type of rainfall, that is your cyclonic rainfall, or it is also known as frontal rainfall. Okay, so let us discuss those rainfall individually. Convectional rainfall, it also occurs due to the convectional current. Okay, convectional current. Now during the daytime, it is mostly this type of rainfall we observe mostly in the equatorial region, or also we can say tropical region. Okay, because during the daytime what happened is we receive vast amount of insulation, isn't it? So those insulation, suppose in the water bodies, it will lead to the immense amount of evaporation takes place, isn't it? It will lead to the immense amount of evaporation. Now those evaporate the water vapor, when it goes in the higher altitude. Okay, in the higher altitude the temperature is always very less, and quickly, due to the large amount of water vapor, quickly it will get it will reach the quickly reach the relative humidity, the 100% of relative humidity also. Okay, so as a result the condensation process will also begin. Okay, now in the evening time what happens is, due to the reaching of the saturated, the air will become very saturated, or the cloud will become saturated, it will reach the 100% of relative humidity also, and finally it will start raining. Okay, so this type of rainfall we also term it as 4 o'clock rainfall also. Why? Because during the daytime lots of evaporation will takes place. Okay, and at the evening time the rainfall will occur. So this is the weather phenomena in a daily basis. This type of weather phenomena every day it occurs in the equatorial areas. Okay, so this type of rainfall has occurs because of the vertical rising of the air. Okay, vertical rising, that means it is a convectional current. Okay, vertical rising of the air is convectional current, if you remember, and the horizontal air is termed as wind, isn't it? So here it has occurred due to the vertical rising of the air, so it is also termed as convectional rainfall. Convectional rainfall. Okay, and another thing, like convectional rainfall is also you know uh, accompanied with the thunderstorms, as well as sometimes the strong winds are also associated with the convectional rainfall. Okay, so this type of rainfall, it's mainly, as I said, mainly present in the equatorial regions or in the tropical regions. Now, let us discuss the relief or the orographic rainfall. Now, relief or the orographic rainfall, relief or oro, okay, means this terms means the mountain or the any elevated surface. Okay, so here what happens is the winds which are blowing, the moisture laden winds, suppose they are blowing towards the certain direction. Now on their direction an obstacle is present or obstruction is present, that is the mountain, that is the relief. Okay, now those winds are forced to rise along the slope of the mountain. It won't carve out a tunnel and it will come out from the other side of the mountain. Now that is not possible, isn't it? So as a result, the winds are forced to rise along the slope of the mountain. And as we know, in the upper atmosphere, the temperature is always less than the always below the freezing point only. So as a result, the condensation process will begin over here, those moisture laden winds. Okay, and more amount of water vapor, when it is added to that clouds, will become saturated. It will become 100% relative humidity. Then the rainfall will occur. Okay, but the same winds will also descend down in the other side of the mountain also, isn't it? But here we won't receive any rainfall on the other side of the mountain, the side in which the moisture laden winds, okay, the side on which the moisture laden winds are, are obstructed. On that side only we will receive the rainfall, but on the other side where the wind is descending down or descending down, there we won't receive any rainfall. Understood? So this side we term it as windward side, and the side which does not receive any rainfall, we term it as leeward side. And the particular area on the other side of the mountain, it is termed as rain shadow zone. Okay, because here we won't receive, or we receive very less or no rainfall at all in this zone. Okay, so this type of rainfall is caused due to the presence of the rainfall, due to the presence of the relief or the oro. So it is known as relief or the orographic rainfall. Okay, now the another rainfall we are going to discuss is the cyclonic or the frontal rainfall. Now, how those rainfall occurs, that also is very simple. This is the Earth's surface. Now, the cold wind, supposedly the cold wind is blowing from this side, and the warm wind is blowing from this side. Okay, or we can say the cold air mass and the warm air mass. Okay, now when they collide with each other, there will be a distinct boundary will formed in between those two air masses. Okay, in between these two air masses, distinct boundary will form. Understood? So here this boundary in between these air masses, it is termed as front. Now one thing, those kinds of boundaries we won't be able to see, remember that. Okay, but a boundary will form. Why? Because the cold air mass will try to remain cold and the warm air mass will try to remain warm. They will not will get mixed up with each other. Okay, they will try to retain their the characteristics. Okay, so as a result, what happens is, along the slope of those, along the slope of those front, the warm wind will start rising and the cold air will start descending downwards. Okay, so when they descend downwards and they, the warm air mass, when it rises above, as a result the condensation process will takes place. Okay, and ultimately rainfall will also occur. Now those types of rainfall has occurred due to the formation of the front. Now in case if the cold air mass was not present over there, then the warm air mass would have eventually blown through parallelly to the earth's surface, or through that place, parallel to the place, and no rainfall would have occurred, isn't it? But here, due to the presence of cold air mass, the warm air mass are forced to rise along the slope of the front, and finally the rainfall will also occurs. Okay, so this type of rainfall has occurs due to the formation of front, so it is also known as frontal rainfall. And sometimes those kinds of, the collision of cold air mass and the warm air mass also led to the formation of cyclones in that particular area. So because of that, it is also termed as cyclonic rainfall. Now students, you might be thinking why the warm air mass will rise along the slope of the front. Okay, so it is because the warm air masses will be very light, isn't it? The density of the warm air mass will be light, whereas the cold air mass will be heavy. So as being light, it will always rise above, and the cold air mass will always descend downwards. Okay, students. So when it is rise above, it will condense and it will lead to the formation, or it will lead to the occurrence of rainfall. Okay. So with this, students, we come to the end of the video, and this all has to be discussed according to the latest reduced ICSE syllabus also. So thank you for watching. See you in the next video. So if you find the video quite helpful and informative, then please share, like, and subscribe the channel. Thank you once again.